Welcome, everyone. Imagine glancing at the night sky and realizing our galaxy contains hundreds of billions of stars, each potentially hosting planets of its own. Current exoplanet detection methods hint at an unimaginable number of Earth-like worlds, places that might harbor life just like ours. Yet for all those possibilities, we've barely scratched the surface in our search for advanced extraterrestrial life. Researchers in SETI, or the Search for Extraterrestrial Intelligence, have spent decades listening for deep space signals, hoping to detect any sign of alien civilizations. Many believe the odds favor contact, yet we have yet to find conclusive evidence of anything out there. That staggering silence, coupled with the sheer scale of our galaxy, sets the stage for one of humanity's most haunting questions. Are we truly alone? Scientists have tried to make sense of this cosmic puzzle through various calculations and hypotheses, one being the famed Drake equation. It reminds us that even a tiny fraction of billions of stars could yield countless civilizations, especially if alien megastructures, like Dyson spheres, exist around distant suns. In other words, if there's even a moderate chance of intelligent life on exoplanets, then by numbers alone, there should be many Kardashev-type species out there. Yet so far, no definitive contact, no signals, no cosmic hello to confirm life beyond Earth. That paradox remains, and that's where the real intrigue begins. Enrico Fermi's famous question, "Where is everybody?" lies at the heart of this grand enigma. The thought goes like this: if the universe teems with potential habitats, and if at least a few lead to intelligent species, we ought to see them, or at least detect signs of alien civilizations. A truly advanced society, say a Type 3 civilization on the Kardashev scale, would harness immense energy, perhaps even spanning entire galaxies. Their mega-projects, be they Dyson spheres or other alien megastructures, should be visible through telescopes as we scan the sky. They'd leave unmistakable traces of technology in the deep space signals that permeate the cosmos. Yet time and again, when astronomers sift through data from radio observatories, they find nothing conclusive. We've picked up intriguing blips here and there, but no clear, undeniable proof of Kardashev aliens or their grand constructions. Some stars, like the famous Tabby's star, have shown mysterious cosmic structures that caused a stir when they dimmed in unpredictable ways. A few optimists suggested the possibility of alien megastructures, but the evidence didn't hold up under scrutiny. All those hopeful moments left us pondering if advanced life has simply chosen not to speak, or if it never existed at all. That fundamental riddle is the Fermi Paradox, and it stands as one of science's greatest unsolved mysteries. Where indeed is everybody? Humanity's quest to connect with extraterrestrial intelligence has been famously carried out through programs like SETI. Scientists around the globe aim enormous radio dishes at the cosmos, analyzing every faint signal that stirs in the background noise. The logic behind it is simple. If a civilization out there uses radio transmissions, we might detect the ripples of their existence. This approach, though, hinges on the assumption that aliens communicate in a manner we can interpret. An assumption some argue is dangerously narrow. A Type 1 species harnesses every available source of energy on its home planet, from wind to solar to nuclear, and controls global systems with relative ease. Graduate to Type 2, and the civilization goes interplanetary, perhaps building a Dyson sphere around its star, an alien megastructure designed to gather nearly all the star's energy. Now imagine a Type 3 civilization. That's when mastery extends across an entire galaxy. The ability to tap into billions of stars and create mysterious cosmic structures on a scale we can barely comprehend. At that point, these Kardashev aliens would reshape vast regions of space, leaving colossal evidence of their presence. We should be able to spot an empire that vast, yet our observatories keep returning empty-handed. That persistent lack of data nudges many to wonder if such cosmic empires ever arise at all. Still, the notion of a Type 3 civilization search remains compelling for astronomers worldwide. There's a shared sense that if a species can surpass the hurdles that threaten its survival, then grand feats of engineering might follow. The concept of the Kardashev scale isn't just theoretical. It provides a guiding framework for how we conduct the search for advanced extraterrestrial life. Observing unexplained dips in starlight or puzzling infrared signatures leads scientists to ask if a gargantuan megastructure, like a Dyson swarm, might be out there. Some episodes of erratic luminosity, such as those documented at Tabby's star, spark excitement over the possibility of advanced alien engineering. Yet once again, the deeper we investigate, the more mundane explanations tend to emerge. This roller coaster of anticipation and disappointment underscores the paradox. With so many stars and so much time, why haven't we encountered irrefutable signs of alien civilizations? Perhaps the answer lies in the challenges a society faces on its journey up the Kardashev scale, an idea that connects directly with our next chapter. Humanity's quest to connect with extraterrestrial intelligence has been famously carried out through programs like SETI. Scientists around the globe aim enormous radio dishes at the cosmos, analyzing every faint signal that stirs in the background noise. The logic behind it is simple. If a civilization out there uses radio transmissions, we might detect the ripples of their existence. This approach, though, hinges on the assumption that aliens communicate in a manner we can interpret, an assumption some argue is dangerously narrow. Radio waves aren't the only potential giveaway. Mysterious cosmic structures like those hypothesized in theories of Dyson sphere construction could draw our attention through uncharacteristic dimming patterns around a star. Indeed, the idea of finding alien megastructures has loomed ever larger in astronomy's imagination. A Type 2 or Type 3 civilization, presumably armed with enormous energy requirements, might leave behind a detectable footprint. Perhaps an aura of radiation from star-encompassing harvesters, or a peculiar scarcity of visible light due to energy absorption. Our ongoing exoplanet detection methods watch precisely for odd dips in starlight, hoping for that one definitive clue that answers everything. Despite the best efforts of the scientific community, each tantalizing anomaly so far has either remained inconclusive or reverted to natural explanations when studied in depth. Tabby's star ignited endless debates, but dust clouds turned out to be a more realistic cause for its unusual behavior. Other alleged wow signals in radio astronomy have likewise failed to confirm a genuine alien source. Each false alarm further emphasizes how vast and elusive the galaxy can be. Detecting signs of alien civilizations, no matter how advanced, is a bit like searching a boundless ocean for a single ripple. The puzzle intensifies once we factor in the time it takes for signals to travel. A radio wave crossing hundreds, if not thousands of light years might arrive long after the civilization that sent it has vanished. Or we may have missed the window entirely. These sobering realizations remind us that just because we haven't found anyone yet doesn't imply they're not out there. The sheer idea of a Type 3 civilization spanning an entire galaxy may sound like science fiction, yet the concept remains a serious subject in the scientific community. If such Kardashev aliens exist, they would have immense technological means to harness stellar energy on a colossal scale. One might picture armadas of solar collectors orbiting countless stars, or advanced engineering projects that manipulate cosmic structures in ways our minds can hardly fathom. With that level of power, conventional wisdom suggests we ought to see some unmistakable clues, perhaps whole regions of space dimmed or altered by their engineering feats. The paradox, of course, is that the cosmos still looks stubbornly natural. We don't observe a galaxy stripped of its starlight, nor do we detect star systems systematically enclosed by Dyson spheres. To make matters more intriguing, our instruments occasionally catch peculiar readings, odd fluctuations in brightness, unanticipated levels of infrared emissions, or signals that don't match known cosmic phenomena. These fleeting anomalies often rouse excitement, only to fade under rigorous investigation. Critics note that with billions of stars and countless points of data to sift through, occasional anomalies arise merely by chance. Supporters, on the other hand, counter that if intelligent beings truly exist on such a massive scale, one strong piece of evidence would upend all our doubts. One possibility is that advanced alien civilizations choose to camouflage themselves. The so-called dark forest hypothesis paints a grim picture of civilizations hunkering down, fearful of drawing attention in an unforgiving universe. Another line of thought argues that any society clever enough to reach Type 3 status might have transcended our observational methods, using technologies beyond our comprehension, quantum communication, or energy sources that emit no telltale traces. If that's the case, we could stare straight at these galactic empires and remain none the wiser. Others propose the idea of a cosmic filter that wipes out promising species before they can flourish at galactic scale. We have no proof that such a filter is real, yet the pattern of silence prompts uneasy speculation. Are we simply too early in our search, or is the great filter something that stops life from ever reaching these exalted heights? Whatever the truth, the dream of finding a Type 3 civilization endures among astronomers, futurists, and armchair detectives alike. The stakes are high. Proof of an ultra-advanced society would revolutionize our understanding of life's potential and force us to reckon with what might lie ahead for our own species. Finding evidence of alien megastructures or deep space signals has always relied on meticulous observation of vast swathes of sky. Yet as telescopes grow more powerful and data sets balloon in size, the role of artificial intelligence becomes increasingly essential. Machine learning algorithms, trained to spot even the subtlest anomalies in a sea of ordinary readings, are an invaluable resource for future SETI efforts. Traditional methods, where researchers scan readouts by eye or code simplistic filters, simply cannot keep pace with the trillions of data points pouring in from radio and optical surveys. AI, by contrast, can uncover patterns indicative of advanced engineering, perhaps unusual starlight dips or radio pulses too structured to be random cosmic noise. These technological leaps dovetail with new missions in exoplanet detection. Upcoming observatories, both Earth-based and in orbit, aim for ever finer detail when measuring planetary atmospheres, stellar variations, and any signs of alien civilizations. Astronomers now speak openly of techno-signatures, a term referring to the chemical or electromagnetic traces left by sophisticated life. The hope is that a powerful AI combing through exabytes of spectral data might isolate a puzzling signature, a star encircled by some advanced infrastructure or a planetary atmosphere altered by industrial-scale processes. Such developments could transform how we interpret the silence that has thus far pervaded our search. Perhaps our instruments have already captured faint echoes of Kardashev aliens, but we've lacked the analytical heft to tease those signals from the background. That's where AI becomes more than a mere tool. It's a collaborator in the grand pursuit of knowledge. If any civilization has left detectable footprints, especially on the threshold of Type 2 or Type 3 on the Kardashev scale, we stand a better chance than ever of spotting them. Yet this technology doesn't just bolster our hopes for discovery, it also heightens ethical debates over how we respond if we do find something. Should we send out powerful broadcasts of our own, announcing our presence, or remain cautious in case the dark forest vision proves accurate? The increasingly sophisticated capabilities of AI, combined with massive global telescopes, may yield an answer sooner than we realize. A single, indisputable detection of a deep space signal could reshape everything we know about cosmic life, and with it, the story of humanity's place in the universe. Our universe is vast enough to house countless Earth-like worlds, and if the Kardashev scale is any indication, there's no shortage of ways an ambitious species might ascend to unimaginable heights. The calculations, probabilities, and thought experiments all point to the idea that alien civilizations could be as common as sand grains on a beach. Yet, the Fermi Paradox reminds us that every glimpse we've caught of the cosmos appears stubbornly silent. It's a disquieting contrast, and one that leads to questions both sobering and hopeful. Do civilizations tend to self-destruct before they can reach Type 2 or Type 3 status, or do they simply hide their presence for fear of predators lurking out there? We've looked for signs of alien megastructures around distant stars, listened for deep space signals that might betray an advanced mind, and turned our lenses towards every intriguing wobble and dimming. Each time, nature seems to keep its secrets well, but that hasn't stopped us. New observatories and AI-driven analyses may yet unlock the data hidden in the cosmic static. Perhaps the next wave of exoplanet detection methods will spot the chemical hallmark of industry on some faraway world, or a subtle, unnatural flicker in a star's light curve might reveal a Dyson sphere under construction by Kardashev aliens we've never imagined. Even if the great filter lies somewhere ahead, the search itself grants us perspective. It shows us how precious life is and how easily our dreams could slip away if we fail to grow responsibly. It also sparks the realization that we might well be cosmic pioneers, tasked with carrying life beyond this planet in case we stand alone. Regardless of where the truth lies, the journey towards understanding our cosmic neighborhood has become an odyssey for humanity. With every telescope we launch and every faint signal we pass, we draw one step closer to an answer. The question remains, what will we do once we find out whether we share this grand expanse or whether it's ours alone?